good morning, everybody. Thank you very much for having me today. I will start with an acronym, COGITO. Don't worry about it. It's just a project title. It's a Horizon 2020 funded project that includes about 13 partners. And the purpose of the project is to indeed do digital twinning of construction projects. Now, you'll see here a life cycle of a building project or infrastructure asset project, going at the top from design, construction, operation, and demolition. The focus of our project is construction stage. A lot of digital twinning work you see is very focused on the operational stage of assets. We are focused on the project delivery and how digital twinning technology can help us in the project delivery. Why does it matter? Well, the construction industry is very important. It's about 9% of EU GDP, worth about 1.6 trillion euros, I think. I put a pound here, but I think it's euros. It's probably the same now. 8% of the EU employment, so about 18 million jobs. So it's very important, but unfortunately, it also has a number of problems. It's seen broadly poor productivity growth for quite a number of years. It's about 1% annual gains. It's continuously trying to improve, but it struggles. And it has a lot of under-delivery performance. There are lots of rework that costs about 5% overall contract value. Time overruns, most projects actually go over time, about 7% of total work hours. And there are some structural issues like the highly fragmented nature of the industry with loads of small SMEs and limited levels of digitalization. The last 2 points are actually important. They are both an opportunity. The fragmentation can really be helped with the use of digitalization. But the other one is obviously a little bit of a challenge to integrate digital twinning because the industry starts from, let's say, a low ground. But we still want to focus on that and try to address especially the rework and time overruns and the performance. What do we propose? We propose to develop a digital 4.0 methodology that has the following ideas. We use what we call as-planned data, and that is data that emerges from the design and planning phases, such as the 3D model, the schedule, budgets, cost information, and so forth. We combine this with real data, and I wouldn't say real time, I'd say right time data coming from the delivery of projects. Some of it is real time, some of it is not. And that includes reality capture data like 3D scanning, images, but also IoT sensors that can be used to track resources. We integrate all this into our construction phase digital twin platform. And this enables a number of use cases that we are demonstrating in this project. I have 4 here, or 3 main actually, and one is kind of related to the 3 others. The first one is secure workflow planning and monitoring. So integrate all these data to do efficient planning, but also continuous monitoring of the delivery, the production, and adjusting things in real time. Dynamic safety planning and monitoring, again, improve safety planning, but also continuously monitoring and adjusting activities accordingly. And digitalized planning and delivery of visual and geometric quality control, and do all this in an integrated way with the digital twin platform. And to visualize all the results and help with the decision making for project management professionals, we have integrated data information visualization with both an off-site visualization tool, so to essentially mine and get access to information in the digital twin platform, but also an on-site one using augmented reality technology. Today, for the rest of this presentation, I will focus only on the core of the digital twin based solution we have, and that is the digital twin platform. What is it composed of? First, we're working very hard on developing an ontology network that integrates all the information, data, information, knowledge that is relevant to deliver construction projects effectively. That includes collecting data from a number of domains. There's data about the product itself, the project and the construction site, the process of delivering construction, the reality capture data that we get from the site, and data related to the applications, the use cases. And within this, I mentioned the product is the building infrastructure asset and the construction site itself. The process, we need to collect and link data related to the schedule, workflow, and the resources. Reality capture, I mentioned earlier, we collect visual in the form of 2D, 3D data, as well as IoT sensor data, like position data for our location data for equipment and workers. And then we produce information about or that supports workflow management, health and safety management, and quality control management. The 5 ontology modules that have been developed to date, and you can see a snapshot here. It's just a high-level snapshot about the product, the process, and the applications. And very importantly, we don't try to develop these things from scratch. We actually look at what already exists in terms of ontology that are widely used in this or other industries. And you have a list here of ETSI ontologies or WC3 ontologies. And this enables a more reusable and extendable solution. If you're interested in looking at this, this is the link to our current ontology. It's not updated in real time, but we create an update information. So it's publicly available. In terms of the implementation of the digital twin platform, if you're curious about technologies, we essentially have 4 databases that we use. One is called Triple Store. This is about storing the semantic network that links all the data. And then we have another 3 databases, one relational for project data, one for what we call IFC data, which is essentially the building data, and then for real-time data, so time series data, the IoT data. And then all this information is then linked through the Triple Store. And the digital platform is then provides a number of services. I won't go into detail what you would expect about manipulating data and making sure it is of the right quality, etc. Just to give you a quick snapshot, on the left-hand side here, you have a view of the network diagram that we actually have for our solution. And on the right-hand side is an example of query that was submitted to the digital twin platform. So the top is, the whole 3D model, but a query can be to get what we call the 4D snap. That is, what is the building model supposed to look like at time t? And that is provided automatically by digital twin platform to support the use case that needs that data. Finally, very importantly, for those who are familiar with this, we support IFC 4.3, which is essentially 4x3, which is about infrastructure type data, which is very new. And I'm just being told this is the end of my time. And we also have services that enables checking the data. I guess I mentioned that the data quality through another acronym called MVD, Model View Definitions, which enables us to define what we want very specifically for each of the use cases. And this is very important because we don't want to extract the whole database every time we need some data. We need a very specific subset of information in the database. Okay, that's all with me. I'm slightly over time, but I hope you enjoy this and I look forward for your questions.